Today we're going to explore the three different forms of a quadratic equation. So we're going to start with standard form. Standard form is what we're used to seeing. I'm going to call it S of x, and that's ax squared plus bx plus c. That's our standard form, the one we use when we're doing the quadratic formula, etc. So from this form, the easiest thing to find is the y-intercept. Your y-intercept is always going to be 0, c, that constant value. The axis of symmetry is found by this equation, x equals negative b over 2a. And our concavity is actually going to be the same on all of them. Concavity means does it open up or down? So if it's a positive a, it opens up. If it's a negative a, it opens down. And that's going to hold true for all of them. The next form is vertex form. So I'm going to call this v of x. So in vertex form, we've got our a value still, x minus h squared plus k. So in vertex form, the vertex is found by taking h and k. Notice what happened to the h. It was the opposite of what was in the parentheses. Our axis of symmetry is going to be x equals h. The axis of symmetry is always going to go through the x coordinate of the vertex. Again, concavity, a positive a goes up, a negative a goes down. Then we have our factored form. Factored form is just what it sounds like. It's been factored. We have our a value, and we're going to put x minus r sub 1, x minus r sub 2. And those r's are going to represent the roots. The x-intercepts are also called roots. So that your two roots in this case would be are going to be r1, comma 0, and r2, comma 0. For the x-intercepts, the y-coordinate is 0. For the y-intercepts, the x-coordinate is 0. Now our vertex, we can still find if we know the roots, because our x-coordinate of the vertex is smack dab in the middle between those two roots. And from this, we could plug our x value in to find the rest of the vertex. The axis of symmetry is exactly this. It's right in the middle between the two roots. And of course, concavity, positive goes up, a negative goes down. So we're going to use what we call the attributes of our equations and of our graph to see if we can figure out what equation might match a particular graph. So keep in mind these forms. Standard form, the intercept is obvious. Vertex, of course, the vertex is obvious. And factored form, the roots are obvious. And concavity is obvious on each one. So let's take a look at this first example. So if I look at this one, some things that I notice, it's going down. So it's got a negative a value. Now it has two roots, and notice where they are. It's got two negative roots. And look at where the vertex is. My vertex is in quadrant 2, which is negative, positive. And the y-intercept for this graph is a negative number because somewhere down here, this is going to hit the y-axis and it's going to be at a negative. So the y-intercept is negative. We're going to look at these equations now and see if any of these equations could possibly match what we just described. So I know it's got a negative a value. So anything that does not have a negative a value, I'm going to eliminate. That's negative, that's a positive. Okay. It's got two negative roots. So let's look at these two, number 1 and number 7, are in factored form. So what would be the roots of this? Well, remember the roots are whatever makes it equal 0. So for this one, x plus 1 would have a root of -1, and x plus 4 would have a root of -4. Well, that's a possibility. So I'm going to circle number 1. Could be. Now let's look at number 7. It's going down, but then look, my roots are -2 and +3. Well, that doesn't fit this graph. So I'm going to cross out number 7. Now I'm going to skip to 6 and 8 because these are in vertex form. We already identified they were going down. My vertex is a negative and a positive. So if I look at number 6, it's got a vertex at +6, +3. Because remember, it's the opposite sign. So 6, 3 cannot be this vertex. So number 6 is out. How about number 8? It has a vertex at -6, +3. Well, that's a possibility. So we'll circle that one. And now let's take a look at number 2. It's in standard form. We know it's going down. And what do we know about the y-intercept? Remember, this constant value right here is the y-intercept. Well, the y-intercept is negative. So I think this could be a possibility as well, just by looking at our graph and our characteristics, our attributes. So that's how this process works. Let's take a look at letter B. Letter B has a positive a value because it's going up. The roots are both positive, so 2 positive roots. How about the vertex? Well, the vertex is in quadrant 4, so that's a positive, negative vertex. Positive x value, negative y value. And the y-intercept on this one, so as this one goes up and up and up, eventually it's going to hit the y-axis, and it's going to be a positive y-intercept. So let's look at all of our choices here. First, let's eliminate anything that is not a positive a value. So 1, 3, oh, that's a negative a value. He's out. Positive, oh, there's another negative a value. So number 4 is out. All right, let's check the roots on the factored ones. That's this one, number 2. For my roots on this one, I've got an 8 and a -2. The roots are whatever makes it equal 0. Those are the x-intercepts. So they're both supposed to be positive. So that one's out. How about number 8? Well, these roots are -3 and -3. First of all, they're the same number. I have 2 different ones, and they're both negative. So number 8 is gone. Let's check anything in vertex form. I need a positive, negative. So number 1, the vertex would be 75, -92. Now, granted, this scale doesn't quite look like that, but it does fit the negative positive, and if the scale was just right, this one could work. Number 7 is also in vertex form. What is the vertex of number 7? Well, it looks like -4, -2, which is not possible for this point. So number 7 is not in it. Let's look at 3 and 6 because they're the only ones we have left. So those are in standard form. Let's check for the y-intercepts. So my y-intercept for number 3 is, remember, the constant number in the back. Positive 240. Could that hit positive 240? It could. So that's a possibility. And let's check this one. Oh, what's this y-intercept? -2. Not a chance. So that one's out. All right, let's take a look at letter C. So we look at this graph. Notice it has no intercepts. Let's start with the a value. It's going up, so positive a. It has no 0 roots. So we're going to learn later in the unit that these are imaginary roots because they're not real. My vertex is in quadrant 1, so it's positive, positive. And my y-intercept is also positive. All right, so let's take a look. A positive A value. Check all these out. They are all positive. Okay. It has no real roots. I should say no real roots because it does have roots. Well, number 1 definitely has roots at -1 and +5. That's not the right graph. Number 4 has roots at -1 and -5. My graph does not have those roots. Let's check the vertex. The vertex has to be positive, positive. So take a look at number 5. It has a vertex of 6, 5. Okay, that could work. Let's take a look at number 2. It has a vertex of -6, -5. That's not in quadrant 1. All right, all that's left now is the y-intercepts. So look at number 3. I've got a positive A value, and I have a y-intercept of 10,010. Well, it's positive, so this could be. And let's take a look at number 6. It has a negative y-intercept. This definitely does not have a negative y-intercept, so that can't be. So now we turn the page and we get to the next section, which asks us to write each equation in the other forms. So if it's in standard form, write it in vertex and factored, and so on. So we're just going to practice going through the forms. So we're always going to, whatever they give us, we're going to go to standard form first, and then we can do the others. So this is in factored form. So to get it into standard form, I need to do some multiplication. So I'm going to start, I'm going to distribute the 2 last. You could do it first, but I'm going to multiply x minus 4 times x minus 6, and then I'll distribute my 2. So I get x squared minus 6x minus 4x plus 24. And I'm now in standard form. I'll change that to an S because what I'm about to write is the standard form of this. I have 2s of x. I got this. So I have s of x equals 2x squared. Let's see, negative 6x minus 4x is negative 10. So that's negative 20x plus 48. That is the standard form of that equation. Now we're going to go to factored form. In factored form, it's just what it sounds like. We want to factor. We're going to start with the GCF, which was the 2 that we just distributed. And now I'm looking for factors of 24 that add up to negative 10. And I think I know what those are. X minus, we came from factored form. I'm being silly. We want to get this into vertex form from standard form. Forgive me there. All right, so the vertex is found, let me get this where you can see it. The vertex, the x coordinate of the vertex is negative b over 2a. So start at standard form, negative b. So b is negative 20. So negative b, the opposite of negative 20, is positive 20. A is 2. So we do 2a. So 20 divided by 4, my x coordinate is 5. From there, I can find my y coordinate by just plugging the 5 in. So I get y equals, I'm going to plug 5 into my standard form. 2 times 5 squared minus 20 times 5 plus 48. And yes, we have to do this without a calculator. So 5 squared is 25, that's 50. 20 times 5 is 100. And 50 minus 100 is negative 50 plus 48, which is just negative 2. So my vertex is 5, negative 2. So here's what that equation looks like. My A value was 2. It's going to stay 2 for the entire problem. Now my vertex, my x coordinate was 5, so x minus 5 squared, and my y coordinate was negative 2. So we go to standard form, then we find the vertex, and we plug it back into vertex form. We're going to practice that a couple more times just to get better at it. All right, this one starts in vertex form. So we're going to do something very similar to what we did over here. We're going to multiply it out to get standard form first, and then we'll factor it. So I'm going to do the same thing I did on the first one. I'm going to multiply the x plus 2 times x plus 2 first. Then I'll distribute the negative 2. Now, some of you have this little formula memorized, the x squared or a squared plus 2ab plus b squared. That's great. If not, we're just going to x squared plus 2x plus 2x plus 4. So that comes to x squared plus 4x plus 4. So I kind of did that in-between step in my head. Now I'm going to distribute the negative 2. Negative 2x squared minus 8x minus 8 plus 32. And that gives me the standard form, which is negative 2x minus negative 2x squared minus 8x plus 24. There's my standard form. Now to go to factored form, I am just going to factor. I'm going to start by taking the GCF of negative 2, which gives me x squared, be careful, plus 4x minus 12. Now I just need factors of negative 12 that add up to positive 4. So that's x plus 6, x minus 2. And that is our factored form. Now we start with standard form. And you can go either way. You can go to factored or vertex. I'm going to start with factored. So to go to factored form, I need to take out my GCF of negative 2. So that's x squared plus 4x minus 21. So my factored form, I need factors of negative 21 that add up to 4. I think that's plus 7 and minus 3. Now, I do want you to notice every time we went to factored form, we took out whatever was in front of x squared. It was negative 2. We factored out a negative 2 because we want this to just say x squared. So there is my factored form. Now let's find the vertex. So remember we said the x coordinate of the vertex was negative b over 2a. So b is negative 8. So negative b is positive 8 over 2a, and a is negative 2. So 8 divided by negative 4, my x coordinate is negative 2. And now I'm going to plug it back in to find my y coordinate. Be careful just plugging in a negative to your equation. So negative 2 squared is positive 4 times negative 2. Negative 8 times negative 2 is positive 16 plus 42. So negative 8 plus 16 is 8. 8 plus 42 is 50. So now I have my vertex. I have my x-coordinate was -2, my y-coordinate was 50. So vertex form, the a value is still -2, x minus the x-coordinate, so x plus 2 squared plus 50. And there we have it. All right, last little bit. We gave you these graphs, and we want you to write the equations for us. Now I've given you the a value. In another lesson, we're going to learn how to find the a value given this information. So let's start with factored form. Notice I have roots at 3, 0 and 25, 0. So factored form, I start with my a value, -1, and if you don't put, you can put in the negative without the 1, x minus 3, x minus 25. Those were my roots. Vertex form. See, we gave you the vertex up here. So the vertex form is still going to have a -1 for an a value, x minus 14 squared plus 121. And notice I've already got the y equals set up for you. So if you're writing it by yourself, you have to include the y equals. Standard form is just multiplying one of these out. I think the first one's going to be the easiest to multiply out. So I'm going to multiply x squared minus 25x minus 3x plus 75. That's -28x. So when I distribute my negative, I get -x squared plus 28x minus 75. And there's my standard form. We're going to do the same thing again with a different graph. So we have this graph. A is 3. I have roots, and I have a vertex. So starting with factored form, a is 3. Now this root was 0. You can write x minus 0 if you want to, or you could just put x. And this root is 4, so x minus 4. So if you wrote that as x minus 0, that's fine. Now my vertex form, since I know my vertex is 2, -12, I keep my a value as 3, x minus 2 squared, and then minus 12. Standard form, I just have to multiply one of these out. I think this one's pretty easy. 3x squared minus 12x. And that would be standard form for this. Notice in this one, if I put a plus 0 at the end, that's my y-intercept, which is the y-intercept. So there, we're going to play around with these 3 forms of these equations, and they're going to serve us well through this entire unit on quadratics.